Hello, grade 11 chemistry students. It's Mr. Miller here again with another lesson from our uh, our unit on quantities in chemical reactions. So we're going to have a conversation about percent composition. So as you know, we've been talking about compounds, we've been talking about matter, we've been talking about a lot of things, and compounds are made of a fixed number of atoms in a fixed proportion to one another. So for example, we have here carbon dioxide. This is a picture of carbon dioxide. You can recognize it from its linear shape. And for every carbon dioxide molecule, we've always got one carbon atom, we've got two oxygen atoms. Next down the list here we have water, so it's two hydrogens and one oxygen, and it always exists that way, and that's how we get hydrogen bonds, and it's got that bent shape that we're so familiar with now. And down below it here we've also got, this is CH4, or also known as methane. Okay, so methane there, it's always got the one carbon, and it's always got 1, 2, 3, 4 hydrogens attached to the carbon. Okay, so they always come in those proportions of elements, one to another. Back in France in the early 1900s, there was a man named Joseph Louis Proust, and he came up with this law, the law of definite proportions, and it stated that elements in a compound are always present in the same proportion by mass. And that kind of stands to reason, I guess, if you think about it, because every compound has always got these elements in the same proportion every time, and the elements themselves always have the same mass. Carbon, usually, with the exception of some isotopes, usually has a mass somewhere close to 12, and oxygen usually has a mass somewhere close to 16, as we've talked about. So makes sense that carbon dioxide will always have carbon in a certain percentage by mass, and oxygen in a certain percentage by mass within that molecule. Okay, so I'm just going to define something now here. So this thing called mass percentage. Okay, the mass percentage, so an element's mass percent within a compound is going to be the mass of the element within the compound divided by the total mass of the compound. Okay, and then multiply that by 100%, and that's going to give you your total mass percentage for an element. So as an example here, we've got a little problem. Okay, so the example here says find the mass percent of the barium in barium chloride, given that the mass of the barium was expected to be 685 grams and the rest of the material was believed to be 1.2 kilograms. Okay, so quite simply, to calculate the mass percent, we'll just go, okay, so mass percent, okay, is equal to mass of the element. So in this case, it's going to be the mass of the barium, and we'll divide it by the total mass of the rest of the compound, and then multiply that by 100%. Okay, I'm just going to give myself a little more room here. Okay, so that's going to be equal to the mass of the barium. In this case, it's going to be 685 grams. Divide that by the rest of the materials. Okay, so mass percent of the barium and barium chloride. The mass of the barium was 685. The rest of the material was 1.2 kilograms. So the 1.2 kilograms will be 1,200 grams plus the mass of the barium, which is 685 grams. Okay, and then we'll take that and we'll multiply by 100%. Okay, doing a little calculation here. 6, 8, we're going to have 685 grams divided by 1,885 grams multiplied by 100%. Okay, and that gives us, okay, so 36.3%. So in this sample, in this example, the percentage of barium was 36.3%. The rest of the material was made up of chlorine, so that would have been the chlorine in the barium chloride. Okay, so the sum of all the mass percent values, so we calculate mass percent, the sum of all the different mass percent values for all the different elements within a compound has got to be equal to 100%, as we're showing here. So the sum of all the mass percent values will be 100%. So therefore, it stands to reason, if we've got barium chloride and the barium makes up 36.3% of the barium chloride, then the percentage of the chlorine, or the mass percentage of the chlorine, mass percent for chlorine is going to be equal to the 100% subtract the 36.3% for barium. Okay, and that's going to be 63.66. Okay, so in this example of barium chloride, with 685 grams being dedicated to barium, we're going to have 36.3% mass percent of barium, and then the rest is the 63.66% as chlorine. Okay. Another term to learn here is percent composition, and basically all that is a summary of the mass percent for each element within a compound. Okay, so we'll just do a quick example here of a calculation of percent composition. Basically, we've actually done that for this example here. So to summarize what we've learned about this sample, which had 685 grams of barium and 1.2 kilograms of chlorine. If we had to present it as a percent composition, we would say, so barium was our 36.3% composition, and then chlorine 63.66 mass percent. Okay. So moving on to a new example.